You know, you can
Okay.
color code it and
The white color, and is it the green or the magenta that would be similar in value? Because this is not just from zero to, this is not a scale from, is this a
no.
zero? How is this color
I
bar
think
made?
there's no real color bar. The color bar here tells you how the mix of colors work. The magenta
It's
tells
just
you got
mixing
a
them.
reasonably dense structure and with a gradient, but not much curvature on it. So you're
Mhm.
looking at a series of faults or step faults or edges rather than the structural shape. The green will tell you about the curvature and where it's mixed with the gradient. You know, there's a
Yeah.
certain amount of curvature and gradient on that, so it's more of a rounded shaped feature, which is generally of lower density than the rocks around it. So it's kind of more qualitative interpretation rather than quantitative. So the idea is that you think of the color mixes and what do they mean, and you can look at that pyramid color bar, so to speak, and then start thinking about it geologically as to what that might correspond to.
So the white color
Um,
is coming from the very tip of the pyramid,
yeah,
the TZZ.
yeah, it is. Yeah, and the white color is actually from the central point where you have an equal mix of red, green, and blue.
Oh, that's the white.
Oh, okay.
Yeah, yeah.
Oh, okay.
So you have an equal amount of each. That's where you get the white. So it's going to be a higher density. It's going to be a higher gradient. It's going to be high curvature. So you know you got a very, very, you got a target.
I was gonna say those.
You got a target to get
Okay.
excited about if you're a mineral explorer. Put it that way. Yeah.
Oh my gosh, because I mean the resolution that you're pulling out of that igneous intrusive feature, especially because I mean we were discussing it last night as
Right.
far as when we were kind of going over this PowerPoint and how you can actually see the evolution of that shear system along with how that igneous body is intruding in. You can see that there was definitely a primary event, and then you can definitely see there was a secondary event after, and that's ring around
That
the
was
outside.
overprinted by the primary too.
That's right. Yeah.
It's yeah.
So you shear it, pop, intrusion happens along tension. So along this way of the shear, right?
Mhm.
You're going like north 70, or no, what would that be? Like 45 degrees east between the envelopes of the shear.
Yeah.
Bow, you shear it like this. You have tension right across that big feature. The crazy part I'm trying to figure out is that big folded, banded, iron banded formation. That fold happened, I think, at the shear envelope. So that's happening
Yeah. Yes.
along
I would
that,
probably well, it may have predated the shearing.
or it even predated.
Mhm.
Then this
Yeah.
big crack or this force comes in, causing this tension, and like you said, you do that again, even using the same convergent vectors or rotating them slightly.
Yeah.
Pop it again, and you have a second event that's outside of the inner core of that feature, and it's being
What's blowing my
wrenched.
mind is because I've looked at very little data in the southern hemisphere, right? Majority of my data that I've looked at is in the northern hemisphere.
Yeah.
So the primary trend of those faults, based on what you're seeing around the tectonic equator, being like that north 70 east,
Yep.
right? And then now you're on the southern hemisphere, just flip that, right?
Oh shit.
Or north 70 west in the
Oh,
northern hemisphere, and the southern hemisphere would be the other orientation. So yeah, so I could see the banded iron formation. Oh my god, this is awesome. This is awesome. Sorry, brain is thinking of 1,000 different things, and probably 90% of them are incorrect, but it's
We're phone calls away
Yeah.
from other geologists telling us exactly what's going on here. What?
Yeah, and also this one, you know, that you can think about the kimberlite because you know about the Juaneng diamond mine. That's a kimberlite pipe, but there are other kimberlites right across this several block. They're much smaller in size, and you don't really see them in this particular display. But kimberlites are something that's sourced directly from the mantle.
Right.
Mhm.
Pipes that extend to that distance. So you got a very old, ancient cratonic rock system extending to depths of 40, 50 kilometers, and under duress and pressure, these pipes
It's
they've
just
been
crazy to
shooting
think
up.
about. Ugh.
And where you got intersecting structures and the like, it's ready to be exploited. So
Mhm.
you got a pipe system in kimberlite field just exploiting those cracks and
Wow.
sending its diamonds into this section.
Amazing. No, this
Yeah,
is amazing.
Mhm.
It is. It's